bit more about QUICKSURFACE. QUICKSURFACE is a standalone application that allows you to take scan data and recreate a CAD model, which you can then export for further use into any other CAD packages. Our main focus is to make this software easy to use, understandable, and we provide tools for mesh editing that you can improve the mesh and send it to a printer, or you can recreate a perfect CAD model in a parametric way. Our strength is mostly into ease of use and the ability to create a hybrid modeling, which is really powerful when you have a free-form surfaces with our state-of-the-art tools. I think it's good for introduction, so probably we can start. It's already 3 minutes after this, so our colleague Gary will allow whoever comes, but unfortunately, who comes later, he will miss what Victor starts, but it's not the end of the world, so everything should be fine. Okay, I now pass the presentation to Victor's. By the way, if you have questions, type them in the chat. I will follow them, and if it's needed, I will just tell Victor to stop, and then we can answer. So it's not a webinar, it's more of a workshop. Over to you, Victor.
Okay, thanks. So yeah, this online workshop is going to be about how to handle like worked parts. So this is the example that one of our users sent us as an example how to deal with it. And yeah, you can see this part have some deformation in many directions. So I will try to reconstruct it in some manners, and overall we'll try to deal somehow with it. Of course, it's not the most complicated part, but still, it's like people have to understand how to do that, and I guess not much of users have idea how to do that, and overall workflow of reconstructing parts. So yeah, we could start with it right now, I guess. So first of all, of course, we're going to align this part. To align this part, we need some primitives. And as I inspected this part, it looks like here where it was handled, this part more or less is untouched and pretty much not deformed, at least not that much as all the rest part of it. So I'm just going to use this part for reference. Let's go to extract our first primitive. Let's try segmentation tool, see how it goes. Okay, actually, this looks pretty good, I would say. So I'm just going to keep this one. Create and stay. We have our first plane. And since it's radial part, we don't have too much features to put some different primitives. So I'm just going to use sketch to define the rest axis for coordinate system. Pull it just draw it all down like that. But basically, I'm going to use this hole and center hole of this part. So we have two options right now. We have already our slice. These white are slice points of the mesh where where sketch plane is intersecting our scan data. So basically, two options how to deal next. You can go to extract primitives and select all the slice points, and then tell I want to fit here circle. Well, same you can do with lines and so on. Or another option, which is much more faster. You can hold down Shift button and paint all the mesh points, and it automatically fits circle or line or arc. This is going to be our first two entities. Actually, you can mark them as construction ones. I'm going to use centers of these circles to define axes. So since this is done, click OK, exit the sketch. So now we can actually align our part. Let's go to align by coordinate system. Select fitted plane as the first. And we can create it at the top. And select line from sketch. And third reference will be this point. But like that. Click on apply. Later you can come over how it looks like from different positions. So basically, it's what I wanted to achieve. Now we can hide all of this. So and basically now we can start recreating our part. So first of all, I'm going to create 2D sketch for a weld surface. And basically, when you have to deal with such part, which is warped or deformed, you have to keep in mind one thing. So if we're assuming this as a not deformed part, we would like to keep mostly working around this area. So catching geometries here or maximum close to it, or otherwise you will have to define in sketches with some offsets and things like that. So basically, during this workshop, more or less you will see overall how to handle it. But yeah, let's create our first sketch for a weld surface. So, and basically, first I'm going to create, let's say, blank for this part. Let's just create our entities. I'm assuming this one is also horizontal. This. Actually, probably we not need these. And we can just use the first two lines. Let's connect them. Surface. So like this. And here again, so basically we can use this option auto join to join these ends of lines, or another option you can hold Control key and drag around them so the software connects them. So if you repeat the same action with holding Control and dragging around this connected corner, will automatically calculate radius according to mesh. But at this point, I'm going to skip this right now. So we have our sketch for blank of this part. Let's do revolve. Okay. So at this point, we can understand how much this part is deformed. Pretty a lot, actually. But yeah, this zone is pretty intact. So concentrate on this, hiding this rolled solid. And let's actually start doing some geometry that we are going to use as a cutters. And step by step, we're going to get this geometry. So basically, I'm going to create new sketch based on surface of the wall. Something like this. And what I want to create now, right now, so the first like circular part, cylindrical part that will here if you need to see better. The cutter that will create this step right here. I'll go back to sketch. And, well, typically you would like to select all these mesh points and fit some entity, but considering this part is warped, so most likely the result is going to be different. So I'm going to use center point of part initially and just drag it up to mesh points from part, which we assume as a non-defective. Here you can, if you press Control, it automatically snaps to the same mesh points. Let's see, it's like 55 point something. I'll just keep it like it is. At this point, you can see that deformation has changed circularity of this part. So it's not circular anymore in this area because it's warped upwards. Now we can just extrude this sketch. Let's use snapping option, and again we are going to snap in this area. We can unhide our revolved surface and select option cut. Here we can see preview. Okay, so we're good. Let's get back our mesh. Okay, now I'm going to hide solid, and again 2D sketch, this time from top plane, and I'm going to use option outline mesh to see actual contours of cutouts. Initially, now I'm going to create a sketch that I'm going to use as a reference sketch for all upcoming sketches. Basically, I want to fit several circles. Here, make another one here. One somewhere here. And one more. Yeah. So now I'm going to close this sketch and start another one. Again, I'm going to use outline mesh. So the thing is, why I created this reference sketch, to be able to always select the absolutely same radius circles, so we don't have like different radiuses at every next step. So we don't have some like steps on our model, grooves or something. So we're going to have one exact geometry all the time. So we will have perfectly vertical walls where we need that. And just this is more, let's say, how to call it, more advanced approach. So you don't fit your entities all the time according to mesh points, because results can be slightly different every time. So that's why I would suggest to use technique like this. So let's start with okay, maybe let's start with more or less simple things. Here we have common project, other visible sketches, and as long as you have visible previous sketch that I created, you can just click on entities of it. These entities will be projected to your current sketch. Okay, at this point I can hide the previous sketch. So I will rename it to reference sketch. Okay, so what do we need right now is I'm going to create cutters for these cutouts. Basically, right now I have already 2 edges of it, and I have to fit another 2. Again, holding Shift, painting around points. Okay, I have them. Now I'm just going to extend them. Like that. Let's trim away circles. Here I also can use Control and drag around to connect them. Okay, something like that. So basically now we can consider if we want to have already these fillets and cutters, or to create fillets later when the model is more or less done. But I guess this time I'm just going to fillet cutters itself. So I'm going to use 1.5 millimeters radius here. Same here. It's incorrect at the moment. 1.3. Let's make this 1.3 as well. Okay, good. So we have a sketch of the first cutter. Let's just extrude it right now. Like this. Okay, so initially we have to pattern it, but it's not like completely circular pattern. We don't need cutters here. So this time I'm going to use mirror feature. Mirrors across the right plane right now. Okay. Select again. Mirror and across this plane. Okay. Easy way how to pattern our cutters if they're like of such circular and symmetrical part. So we have our first cutters. Yes, I will just leave them right now, and we'll create another one. Go again, sketch, outline. Let's pull back our reference sketch. And this moment, I want to create this big cutout. So initially, I need this circle, this one, and probably this one. Okay. Let's hide our friend sketch. We have what we need right now. Here, I'm going to set line. Let's say another line here, another line here. Let's see how it goes. Okay, it looks pretty great. Let's connect these two. Yeah, we can intersect these lines. Actually, now we can turn on a circle. This. Okay, so according to mesh, we have some deformation or just scan defect. So at this point, I'm going to just eyeball. Okay. Just like with this one. Connect them, connect these two. Radius. Okay, it's not 2. It's 2.1. The same goes here. And this cutter I'm going to create as a 1/4 of this circular part. So I will need another line, vertical here. And this line is going to define how far can I cut this circle. Like this, again, radius, let's say it's same as on opposite side, 2.1 millimeters. So now I need to extend this line. Let's turn circle this away.
Sorry to stop you for a second, Victor. Just to say again, we are recording the webinar, the workshop, and we'll share this later, so don't worry about this. There is a question, where is this project command? It's the last in the modify menu. This is the project, which has been enhanced in the current version. So it's a little bit different of what you know from before. Okay, thank you. Carry on.
So back to this, connecting radius. Okay, at this point it's not what we need. Let's say it's okay, it's more than 3. Let's say it's 5. It's perfectly. So okay, we have 1/4 of this cutter. Okay, half of 1/4 cutter. Again, let's extrude it. Again, doing absolutely same operations as with previous cutters, mirroring to one side, mirroring across the another plane to other side. So right now we have already all of these geometries. So basically, the last cutter on this side, I need part that will create this emboss, or how to call it. I guess it might be called as emboss. Again, we are going back to sketches. Reference sketch. Let's project again this circle and this circle. Okay, let's hide the reference sketch. So right now I need a couple more lines, and actually these lines I'm going to extract from our solids. So this is another cool feature of project command. Now we can project lines from already created solids. Oh, I need this line. Oh, basically, that's all I need. Okay, so let's expand them right now. That. Let's try again. Connect. Connect. Again. So let's create field here. Oh, yeah, actually here in the corner trim button, under it's hiding a couple of filleting options. So there's auto fillet that does absolutely the same what I'm doing as with holding control. But in this case, it's not going to work because we don't have our slice points across this fillet. I'm just going to go fixed size fillet. And I don't know, let's say it's radius 5. And probably something 5.5 probably. Yeah, looks pretty good. And so same on this side. Okay. Again, let's go extrude. Nothing on. Again, we're aiming closer to region that is not deformed. Have this, let's mirror it. So at this point, we can start actually cutting out some parts of our previously made blank. Let's start with this. So select the part you want to cut from. Select cut from selected solid feature and just select your cutter. And it takes away the geometry, intersecting geometry. Okay, good. Now I'm going to hide 2 more. I'm going to select all of them at once. Okay, good. So basically we are this far. We can take a look at some analysis. Yeah, overall it doesn't look bad. Of course, it depends a lot on part. As this is plastic part and it's deformed, it's difficult to judge how close we are to like initial part. So, but considering it's plastic part, probably it's not doing any super precise operations or measurements for some tool fittings or something. Maybe that's pretty much okay. And absolutely same if you are recreating some parts that should fit on axles or something, you should consider the diameters of seats. So, for example, here we have pitch turniness. At the moment we have like almost 16 millimeters, a bit under, so probably it should be 16 or a bit oversized. But well, if you're reconstructing such parts, it would be really good if you would have the actual part on your hands so you can do some manual measurements, because all we know that scanned parts typically have these weird dimensions, so it's like tens of millimeters, of hundreds of millimeters to one or to another side. In most cases, I think it's like an oversized. But yeah, if it's some precision part, just make sure to understand what size of these seats do you need. And same as goes with thickness parts. If this part have to have exact thickness, so this might be important at some point.
Victor, so we have very interesting question here.
Okay.
I'll just read it. Is there a way to split the scan and mirror the good part? You know, so
Yes, of course.
yes,
Okay.
the question is all about on the scan data. Because now this is aligned, maybe you can create one play. Yeah, let's go on.
Yeah, let's go. So
while he is showing, feel free to put the questions here, and when he finishes, I'll read this for him. Okay. Yeah. You go. You go.
yeah, okay. I'm just thinking. So basically, can actually Costa use
Oh.
planes of coordinate system for splitting?
No, you need to create. Just go to construct plane, construct the plane from standard. And just pick where it says type in, just pick the one you like. Yeah. Okay.
This one is good. Okay. So, and it's can split mesh with other solid. At this point, select the solid, or in this case, it's going to be plane. Click on preview. So this is preview. It's going to split this mesh in two parts. Okay. And at this point, we can select one side, click for all this.
You can use. You can go to individual meshes.
Yeah, I'll have to do that. So click on this one. I'm going to leave only this. Another side is being removed. Okay. So and basically.
And you can mirror now the scan data. If you go to scan data.
Yeah.
No, not edit scan data. The scan menu. It says mirror.
Mirror. So let's select it. Mirror. Select plane. And keep original mesh, I guess. So, yes, we can do it this way. Let's see how it looks now. No question actually. Yeah. Not that bad. So do we have some more questions, Costa? Or not yet?
Not at the moment. If you have more to show these exciting tools, so feel free. I'm just waiting for more questions for the whole audience. Don't be afraid. Ask anything you think it's useful.
Yes, exactly. So basically, this is why we are doing this workshop, just to understand what do you want to know. So if you are telling us what you want to know, what you want to see, so we're creating these online workshops. Otherwise, we have to create them, I don't know, by figuring out that by ourselves. So, and pretty often these parts might not be so interesting for you because, well, pretty often we have super complicated parts, and well, if most part of users will be, let's say, some new users and without huge experience, and they are going just to look at it and what's happening. So yeah, that would be really cool if you could tell us what you want to see, what you are interested in. Basically, same, you can write to support email, or you can join our Facebook group, or just somehow reach to us your information and what you want to see. This would be really helpful for us to create new content for you.
Yeah, there are some more questions, Victor, so let's go.
Okay.
And I'm interested in cut modeling from point clouds. Okay, in general, I know this is a huge topic and it's mostly into BIM industry where you scan buildings and stuff. It's a very complex task to convert point clouds into meshes. That's why not many, at least I don't know one successful software to do this. We can import E57, but honestly, we don't want to compete with the players on the market, such as Autodesk and others who are very dedicated to this specific type. Still, you can import E57, you can do some cross sections, you can rotate it on the screen and extract some useful information, but this is how far we go. We are mostly focused on the meshes because the devices, the partners we're working with, they generate meshes easily. So I hope this answers your questions. There was another question. What happened with the tolerance comparison along the mirror plane? Well, what you just saw was a pure mirroring of the mesh to using a specified plane. What you probably get confused is what it's called the symmetry plane, which is a different story. You know, symmetry plane uses perfectly scan data to find where the plane of symmetry is, and then you have this tolerance that you can see. Can you extrude some lines from a sketch and later from the same sketch another lines? That's a good question. We have to check if it was reported, if it's definitely it's a bug. If you cannot, so if you still cannot do this, we will just fix it in the next version. This is what you ask. You want to make the extrusion and then they want to use the same sketch for another extrusion. So yeah, it looks like it's fixed. So oof, thanks God. What else we have? Can you show a countersink function on a hole? Is this a two-step command? I don't know. Victor,
yeah, this comment is coming to us like shortly.
Okay.
So yeah, let's go back to this. And at this point, I noticed that I cut a bit too much out of here. So I'm going back to it. I'm going back to our first extrude. It's to this one. So at this point, I want to insert another line but circle. So I'm going just to convert it from reference sketch. Yes, like this. Okay, so now it's rebuilded and I have all the geometries right now. So at this point, if we're looking at our scan data, on this side, what's left for us are just these two extrudes. So let's create them. Yeah, like this. Basically, to maintain some accuracy, previously I used this call to align our part. So I'm just going to draw a reference line. This point, let's sort. One circle, another circle. Let's map it on this line. This. Basically, now I'm going to set them as a construction geometry. And let's offset. No, actually, I don't need offset for this. I'm just going to use another circle and snap the mesh slice points. I'm going to draw another line like this, and the one on the top. Okay, so at this point we can see that this previously created hole in this part isn't actually perfectly aligned to everything. At this point, we have to consider, should we do something about this or not? Because at this point it seems that it's a bit misaligned. But well, probably in this case, I'm just going to leave as it is, considering we're building everything from scratch from our coordinate system and mirroring everything across the coordinate system. I'm going to use circle here, and I'm going to fit here that will intersect our circle, so that I'm going to mirror it to other side. So basically here, yes, it's like different right now from the scan data, but it's absolutely same distance from center of the circle to outside on both sides. Why it is like that? Well, actually, we don't know. At this point, I can do some tuning. Part of circle I don't need anymore. And this. Okay, now let's pull back our reference sketch. Project this circle. Two lines. Trim it. And this side also. There as well. Okay, so now we see that a preview showing that this is closed counter, so we can extrude it. So let's extrude it. Let's pull back our solid. I'm going to use mapping to this face. Actually, we don't need mesh. There's nothing to face as well. Oh, and at this point, yes, that's new solid. So now I can mirror it. Okay, and so select both features and maybe from here and click this button, combine selected solid. Otherwise, you can find combine command under CAD CAD tools. So here right now, and let's hide and reference sketch. Again, create another sketch. Get back our data. Actually, at this point, I don't actually need some data, and I don't need any reference points from it. So I'm going to use solid as is. Basically, here I have our centers of our boards. And at this moment, let's say it's like 2 millimeters diameter here. And I assume it's saying here 2 millimeters. So extrude this, table snapping, pull through all the part. There it is a new solid. Let's mirror this to the other side again. Again, cut. Okay, so basically now we have our boards here. So at this moment we have to make this cone countersunk for our board. So in order to do that, we're going to fillet menu, set it to chamfer. Here we can select both of them, enter tolerance mode, pull them until they're green. Okay, so now we see that top part is already green and the bottom part isn't. So most likely it's not like 45 degrees. So let's change it to 30. Opposite direction. 60. Okay. 60 gives us pretty good result. But to be honest, at this point, if you don't know more or less standard degrees of countersinks or something, actually you could just come over here, select the circular face, enter sketch for revolve, fit some line to this cone. Take a look, what do we have here? So it's like 30 degrees, 30 point something. So most likely it was designed as 30 degrees. So considering it's 30 degrees on one side, if you are like summarizing that, so it's like 60-degree countersunk. Let's delete this sketch. Let's do as I did it previously. Select these two as well. Meter at 60 degrees angle. Click OK. So something like that. I hope this answered your question about countersunks. If not, please write the comment again. We will try to answer a different way if this is not what you mean. And basically, this way you can continue to build your parts. After that, we can come over by here and probably we want to add some fillet here. don't know if I actually need it right now. So, probably 0.1 or something. Yeah, depends if we really need this. And oh, yeah, well, basically the opposite side is pretty much the same, just a bit different shape. And considering we're already like 50 minutes on our online workshop, probably I'm just going to leave this part for yourselves as home task or something. So try out. If you have some struggles to model something, to understand something, just reach out to us. Probably if we are going to talk about this part, it would be great if you have some questions you could post in Facebook group, because more people will see this and probably their questions will be answered as well. So probably more people are going to have the same question about the same thing. So it's more useful to post these answers in group where more people see this instead of like chatting over the emails.
Yeah, can you share the STL? The link to this STL is already in the comments, but when we put this on YouTube, we also will add the link for the file in the
description. Yeah. Oh, yes, something like that. I don't know. Do we have some more questions? Probably. Maybe not.
It says, in which state of solid can you mirror? Okay. I guess you can mirror at any point a solid. Yeah.
Well, not only solid, I think we can mirror some surfaces and extruded surfaces, and we can mirror everything. Am I right?
Yes, yes, yes. It's just available where the circular pattern is. If you look on the screen, it says in the main menu, it says circular pattern, linear pattern, but also you can mirror. Yeah, that's correct. Yes.
I don't know. I'm just going to create some handle for this. Looks like it's missing.
Also, while you're doing this, let me explain. Back in the edit sketch mode, people started to get confused with the new version. They see a nice rendering. Yes, here. This indicates, and it's very helpful when you build, that this will be a solid face, which when you extrude, the result will be a solid. It's a good guarantee for you for the next steps. If you have something misconnected, can you delete, for example, the arc on this side? If you delete this, and now if you extrude, this will be a surface. Why I'm explaining this? Because this example is really typical for solid modeling. So you always need to try to keep your shapes as solids, and then you can easily remove material, add, join, so to achieve these results. So the surface type of modeling is not very suitable for this example.
Yeah, basically this color indicates that you have closed loop. And closed loop you can extrude or revolve into solid. If it's not closed loop, you will get just a surface. Either it's like extruded or it's revolved surface.
There is a question, can the whole type be applied before exporting, like threads? No, we don't support so advanced, because the other packages invested a lot in standardization, adding all the possible threads on the market which are available. So they included this as a standard. Well, we believe that this is a simple task that you can finish in any other CAD package, just adding a thread. So yes, when you have a thread, the best is if you just model the hole, which is good enough, and then in your CAD package, you simply add the thread. Can the solid be viewed in transparent mode? Yes, at any point of time. If you
Yes, okay. Right click and your history, not history, or feature tree, click transparent, so it becomes transparent. Or something like that, I think. No, actually, you have to click here.
Okay, it's almost 1 hour. We're not really limited in time, but from our experiences, it's a good timing. So if you have any other questions, now it's good time to ask. If not, you can always send an email to us.
So, okay, I'm done with playing. If you have something more to tell to our users, go on. And since if you don't have,
Well, wait, I would like to say a big thanks for Victor's for the amazing demonstration. I learned a lot also. I'm very happy. So thank you very much, Victor's.
yes, of course, welcome. So this is why we're doing this, so everyone can learn something new.
Yes, and I see some reactions from people. They also learned more, and which is actually the goal of these workshops. Okay, when is the next workshop? We'll do our best to make it as soon as possible to show you all this.
Well, basically, next workshop is like, I don't know, 2-3 weeks, maybe 4 weeks away, but it depends. Like the most, if we have some ideas to show you. So that's why we are asking for you for some information, what you would like to see. So what you don't understand or how to approach this or this part. So we need this information to create something. Otherwise, you will see some super simple parts, reverse engineering, which in most cases won't be interesting for you. So this is cool to discuss.
Yeah, and like you said, in this example was a real problem of a customer. He was happy to share this with Victor, so we managed to show this to everyone. The question is, can we send suggestions for next workshop? Yes, please send us your suggestions, and we'll do our best to make it in this way.
Yes, you can send them to our support email. It's support@quicksurface.com, or you can go to our Facebook group, QUICKSURFACE Facebook group, and post some like, I don't know, new topic there with pictures of your scan data or something and questions. So, and we can start to work from there to create another workshops. Yes, and the recorded video is going to be posted on YouTube, so it's not going to be shared as a video file for everyone. It's going to be publicly available on YouTube. Everyone can watch it at any time.
Oh. Okay. So, Victor, if you click on the chat, Daniel.
Yes, I see that. Very nice. Yeah, very good.
Right. Yeah, this is amazing. Practical example. There is a need, there is a problem, there is a solution.
Yes, exactly. This is the most interesting part. If we have some practical example, not just let's imagine we need this part for something, but where we actually have need for this part. This is cool.
Okay. Okay, in this case, we will finish for today, and we are looking forward to see you again on our next workshop. Thank you.
Yeah. Thanks everyone for joining. See you next time. Bye.
Bye.